Hello, I'm Liam, and today we're stood by rack B1. It's currently an empty rack, but we're going to be showing you how we get this rack prepared and ready for some shiny new dedicated servers. So before we get started, the first thing we'll need to establish is where the front of our rack is and where the rear of our rack is. So you'll see on this side we've got some closed doors, and on this side it's left totally open. So what that's all about is a thing called hot oil containment. So you see from this vent where our cold air from our air conditioning unit rises up and is drawn into the rack by the servers. As it gets taken through the rack, it will cool the servers down to an optimum temperature and is then exhausted out the back. So once we've got a load of warm air out the back of the server, we want it extracted away as fast as possible. And these end of aisle doors, they're going to help make sure that none of our warm air gets mixed with our cold air. We've come out to the west corridor now, and as you have seen, we've had to switch on 2 breakers to power this rack. Now each of those corresponds to a fully separate power feed, and that runs under the floor and up into these 2 fairly hefty Integra PDUs. So these 0U 32 amp power bars, they're so called because they take up not a single U of rack space. And that means that from 1U all the way up to 48U in this rack, we can maximize our space for servery goodness. You can see from these displays that we're getting a good power feed to these PDUs. So now that we've got power all sorted, let's start patching our network into the rack. It all starts up in our W and P patch rooms where our aggregation switches live. These have the job of distributing high-speed internet to every rack in the data center and offer redundancy through diverse paths down to the rack. Once the fiber reaches the rack, it terminates here in this patch panel. As the fiber enters the rack through the floor here, it comes up to this patch panel. Now, we do only have 2 connections to this rack currently, but a full patch panel gives us the option to keep our cabling neat and organized, and it also gives us a structured place to bring in any new connections. So it's really important to remember that when you're setting up a new rack like this is going to be the best opportunity you have to keep things neat and tidy. So if you can avoid any cable spaghetti now, then in 2 to 3 years time, it's really going to pay off for you. And now we come to our first piece of rack mount equipment, our top of rack switch. And where might this go, you ask? Well, you guessed correctly, it's going to be going right at the bottom here. Why is that? Well, we've got our power and we've got our network all the way down at the bottom of the rack, so it makes sense to keep our switch nice and close to them. Would you do it different? Where do you put your top of rack switch? Let us know in the comments. So what switch have we gone for? Well, in the case of this rack, since it will be supporting 10 gigabit servers, we've gone for Juniper's QFX 5100 48T. Now, you might be thinking that's a little bit overkill for this purpose, but I'll explain why. First off, we've got these 48 10 gigabit copper ports. We've also got 6 of these QSFP ports. Now they can be used for either rack uplinks or for stacking an additional switch. And not only that, but we've got Juniper's rock solid reliable platform to put all of our network through. And additionally, these come with quite handy reversible fans at the back, which in our case works really well for us so that we can have air intaken from the front and exhausted out the rear of the rack. So you have seen that our uplinks are these 2 40 gigabit fiber links, and we bond those together using a technology called Link Aggregation Connection Protocol. And what that does is it splits around half of all the packets to one link and half of all the packets to the other. That gives us an effective 80 gigabit per second uplink, and it also comes with the benefit that we've got near instantaneous failover if one link were to have a fault. So I'd like to just quickly draw your attention to this really handy bit of kit. This here is Patchbox's setup.exe. It's a little rack stand, and in my opinion, it's an absolute must-have for these sorts of jobs. It makes setting up these sorts of switches an absolute breeze. Now that we've got our primary network switch configured, it's time to turn our attention to this little guy. This TP-Link switch may not look all that impressive, but it does serve a very important purpose, and that's to connect all the management interfaces across our servers in this rack. At Fraction Servers, we can give you 24/7 access to IPMI, KVM, and virtual media, and that's provided for by this switch right here. All that we have to do is just connect in this little orange cable. And now we've got all of our rack infrastructure done, we just need to put in some servers. For today's installation, we're going to be using a couple of these AMD 7000 series servers. Now these come with the latest 7950X CPU, 128 gigabytes of DDR5 RAM, and come with 4 hot swappable bays on the front, along with 2 internal NVMe disks. So we put these into our trusty 1U Supermicro chassis with dual PSUs, and that means we get to use Supermicro's 1U rails. Now these are some of the easiest rails you'll ever find. All you do is just line it up, click it in, and we're ready to rack. Line up the server, push it in, all done. Now I've come to the back of the rack, and the first thing you might be wondering is why there's so much space. And with these servers, they actually go through our 32 amp PDU budget quite quickly. So what we find is best is to prioritize using a lot of space at the bottom so that we can keep our cable management really, really good, and then have servers stacked all the way to the top of the rack. So the first thing we're going to look at with connectivity here is our power. And obviously we start with our orange feed over here, and this goes in right there, and then we'll finish connecting up the primary feed to this server. So that's all nice and secure in. Note how we're trying to use the shortest cables possible. That's just reducing those big loops that always tend to get knotted with everything else. We can then move on to our management interface. So this black cable here can run behind the TP-Link and then into it, as we explained earlier. And that's management for that server. And finally, we've got our WAN or internet uplink that's going to go into this port here. Once again, tucking it behind the spare switch, keep it all out of the way, and plug into port 2 in this case. So there's a lot of different arguments about which is the best way to cable manage a rack, and lots of different opinions. We tend to find that a middle ground of a good consideration for airflow, but also good consideration for how to access the cables at a later date is really important. So all we're doing is just running them right down the middle of the rack, and then we're going to grab one of these Velcro ties and wrap it up neatly. Before we leave the data floor, a couple more tidying up jobs for us to do. First thing, we're going to take some of this rack blanking, add it in here. Not only does this make the rack look a lot nicer, it also helps with the airflow quite a lot. And then, once that blanking's all in, we can lock up our rack, make sure servers are all secure. And that's the rack done. So next step for us will be logging onto these servers and getting an operating system installed on them. Now, if you'd like to make use of one of these servers, you can head to our website at fractionservers.com, pick it up on a deal. And I hope you found this video informative. If you'd like for us to cover any other data center content, please let us know. And until then, take care.